milk. It's the first food we ever consume. From the tiniest shrew to the massive blue whale, all mammals nourish their young with milk. This vital substance provides essential nutrients in a readily digestible form, fueling the rapid growth and development of newborns. For millennia, milk was solely the domain of infants, a temporary bridge between utter dependence and the ability to consume solid food. This natural order began to shift around 11,000 years ago with the domestication of animals. As humans transitioned from nomadic hunter-gatherers to settled agriculturalists, they began to domesticate animals, including wild aurochs, the ancestors of modern cattle. With the domestication of these animals came a new and readily available food source, milk. Today, the prevalence of lactase persistence varies widely across the globe, reflecting the evolutionary history and cultural practices of different populations. The domestication of dairy animals, particularly cows, marked a turning point in human history and our relationship with milk. No longer solely a food for infants, milk became an integral part of the adult diet in many cultures. From creamy cheeses and rich yogurts to refreshing buttermilk and indulgent ice cream, milk became a versatile ingredient, transforming the culinary landscape. The rise of dairy farming also led to the development of specialized skills and technologies associated with milk production, processing, and storage. Farmers honed their animal husbandry practices, selectively breeding cows for desirable traits such as higher milk yield and docile temperament. The invention of pottery allowed for the storage and transportation of milk, while techniques like fermentation and cheese-making emerged as ways to preserve milk and extend its shelf life. These innovations further solidified milk's place as a dietary staple and contributed to the growth of agricultural societies. However, the mass production and consumption of milk, particularly in industrialized nations, have also raised concerns about its impact on human health, animal welfare, and the environment. As we grapple with these complex issues, it's crucial to examine both the benefits and drawbacks of milk consumption. The ability to digest lactose, the sugar found in milk, varies significantly across the globe. This variation is a testament to the power of natural selection and the interplay between genetics, culture, and the environment. In populations with a long history of pastoralism and dairy farming, lactase persistence, the ability to digest lactose into adulthood, is much more common. They could consume milk without ill effects, providing them with an additional source of nutrition and hydration, especially during times of famine or drought. In contrast, in regions where dairy farming was not traditionally practiced, lactase persistence is less common. For example, in East Asia, where rice and other staple crops formed the foundation of the diet, there was little evolutionary pressure for lactase persistence to evolve. The symptoms of lactose intolerance can range from mild to severe, including bloating, gas, diarrhea, and abdominal cramps. While lactose intolerance is not a life-threatening condition, it can significantly impact quality of life. The prevalence of lactase persistence is not only determined by genetics, but also influenced by cultural practices and environmental factors. Milk is often touted as an essential source of calcium, a mineral crucial for building and maintaining strong bones and teeth. Calcium is indeed vital for bone health, and milk is undoubtedly a good source of this mineral. While milk provides calcium, it also contains other nutrients that contribute to bone health, including vitamin D, phosphorus, and magnesium. Vitamin D in particular plays a crucial role in calcium absorption. Milk is often fortified with vitamin D, further enhancing its contribution to bone health. Studies investigating the link between milk consumption and bone health have yielded mixed results. Some studies have shown a positive association between milk intake and bone mineral density in children and adolescents. However, other studies have found no significant association between milk consumption and bone health in adults. Beyond strong bones, exploring milk's other potential benefits. While milk is most commonly associated with bone health, it also contains a variety of other nutrients that may offer health benefits. Milk is a good source of high-quality protein, providing all the essential amino acids needed for muscle growth, tissue repair, and hormone production. Some studies have suggested that milk consumption may offer protection against certain chronic diseases such as type 2 diabetes and hypertension. However, it's important to note that these studies are observational, meaning they can only show an association between milk consumption and these health outcomes, not a cause and effect relationship. More research, particularly randomized controlled trials, is needed to confirm these potential benefits and determine the optimal amount of milk consumption for different populations. It's also crucial to consider the type of milk consumed. Milk and disease separating fact from fiction. The health effects of milk have been a subject of ongoing debate, with proponents touting its nutritional value and critics raising concerns about potential health risks. One common concern is the potential link between milk consumption and cancer. Some studies have suggested that high milk intake may increase the risk of certain cancers, such as prostate, ovarian, and breast cancer. However, other studies have found no association or even a protective effect of milk consumption on cancer risk. Another concern is the potential for milk to increase the risk of heart disease due to its saturated fat content. However, skim milk and low-fat milk provide similar nutritional benefits to whole milk with significantly less saturated fat. Furthermore, some studies suggest that dairy consumption, particularly fermented dairy products like yogurt and cheese, may actually lower the risk of heart disease. Milk consumption is just one piece of the puzzle, and more research is needed to fully understand its role in health and disease. Environmental footprint, the cost of milk production. While milk offers nutritional value, its production comes at a significant environmental cost. Dairy farming is a resource-intensive industry requiring vast amounts of land, water, and energy. One of the most significant environmental impacts of milk production is greenhouse gas emissions. Dairy cows, like all ruminant animals, produce methane, a potent greenhouse gas during digestion. Methane is a far more potent heat-trapping gas than carbon dioxide, and its emissions from livestock contribute significantly to climate change. In addition to methane emissions, milk production also generates other greenhouse gases, such as carbon dioxide from the transportation of milk and nitrous oxide from fertilizer use on feed crops. Dairy farming requires significant amounts of water for various purposes, including irrigating feed crops, providing drinking water for cows, and cleaning milking equipment. The water footprint of milk production is substantial, and in many regions, dairy farming competes with other water users, such as agriculture and human consumption. Plant-based revolution alternatives to cow's milk. In response to health, ethical, and environmental concerns surrounding cow's milk, plant-based milk alternatives have surged in popularity. These alternatives, derived from sources like soy, almonds, oats, rice, and coconut, offer a variety of options for consumers seeking to reduce their dairy intake or adopt a vegan lifestyle. Plant-based milk alternatives generally have a lower environmental impact than cow's milk. They require less land, water, and energy to produce and generate fewer greenhouse gas emissions. In terms of nutritional content, plant-based milk alternatives vary widely. Many plant-based milk alternatives are fortified with calcium, vitamin D, and other nutrients to make them more comparable to cow's milk. Beyond their environmental and potential health benefits, plant-based milk alternatives also appeal to consumers concerned about animal welfare. The future of dairy innovation and sustainability. As we move forward, the dairy industry faces the challenge of balancing the growing demand for milk products with the need to reduce its environmental impact and address animal welfare concerns. Innovation and sustainability are key to ensuring a future for dairy. One promising avenue is the development of lab-grown dairy products. This technology involves using cell cultures to produce milk proteins, such as casein and whey, without the need for animals. Lab-grown dairy products have the potential to offer the same taste, texture, and nutritional value as traditional dairy products, but with a significantly lower environmental footprint. Another area of innovation is precision fermentation, a process that uses microorganisms to produce specific milk components, such as lactose or casein. In addition to these technological advancements, the dairy industry is also exploring more sustainable farming practices. The future of dairy likely lies in a combination of innovation, sustainability, and consumer choice.